Imagine waking up tomorrow and nothing feels different. The light comes through the window the same way, your phone buzzes the same way, your thoughts feel like your own thoughts, your body feels like your body. There is no glitch, no flicker, no message saying you are inside something. Everything feels continuous, stable, familiar, and yet quietly sitting underneath that normal feeling is a question that doesn't go away once you really notice it. Not a dramatic question, not a sci-fi question, but a very simple one that slips into your mind and stays there. What if all of this, everything you see, touch, hear, and experience, is not the base layer of reality, but something being generated? The reason this question feels unsettling isn't because it sounds wild, but because it starts from something that is already true. You are not directly experiencing reality. You are experiencing a version of it that your brain builds for you. Light hits your eyes, pressure hits your skin, sound waves reach your ears, and your brain turns all of that into a world that feels stable and continuous. But what you actually have access to is not the raw universe. It's a constructed interface, something shaped to help you function, not necessarily something designed to show you everything exactly as it is. And once you realize that your experience is already one step removed from whatever is out there, it becomes a little easier to ask whether there might be another layer beneath that. Now, when people hear the word simulation, they often imagine something very specific, a giant computer somewhere, a hidden observer, a world that is fake in the sense that it could suddenly disappear. But it helps to move away from that image and focus on something more grounded. A simulation, at its core, is simply a system that generates an environment based on rules. It doesn't need to look like a video game. It doesn't need characters walking around with labels above their heads. It just needs to follow consistent patterns that produce a coherent experience. And if you look at the universe through that lens, something interesting starts to happen. The universe is also a system that follows rules, very precise rules, predictable, mathematical, consistent across space and time. Think about gravity for a moment. You don't need to check whether gravity will work today. You don't wake up wondering if objects might float randomly. The same equations that describe motion here also describe motion in distant galaxies. The speed of light remains the same no matter where you measure it. Physical constants don't drift or fluctuate without reason. This kind of consistency is exactly what makes science possible, but it's also exactly what you would expect from a system that is being run according to a set of underlying instructions. Again, this doesn't prove anything, but it creates a parallel that's difficult to ignore once you see it. Now shift your attention to the smallest scales we've been able to study. When scientists look at atoms, particles, and quantum systems, they don't find something that behaves like a tiny solid version of the objects you see around you. They find something far less intuitive. Particles don't always have definite positions. They exist in ranges of possibilities. They behave like waves until something interacts with them, and then suddenly they appear as specific outcomes. It's not just that we don't know where a particle is, it's that, according to the math, it doesn't fully choose a state until measurement happens. This creates a strange situation. Reality, at its most fundamental level, doesn't seem fully resolved all the time. It seems to settle into specific outcomes when interactions occur. If you compare that to how simulations work, there's a similarity that stands out. In many digital systems, details are not fully calculated until they are needed. When you look in a certain direction, more detail appears. When nothing interacts with a region, it doesn't need to be fully processed in the same way. The universe, at least in some interpretations of quantum mechanics, behaves in a way that feels less like a pre-written script and more like something that finalizes details as events unfold. Then there's the idea of limits. The universe is not infinitely flexible. There is a maximum speed, the speed of light. Nothing moves faster than that, no matter how much energy you apply. There are also smallest meaningful scales of space and time, often described through Planck units. Below those scales, our current understanding breaks down. You can't meaningfully talk about distances or durations smaller than that with the theories we have. It's as if reality has a built-in resolution, a smallest unit beyond which the idea of smaller stops making sense in a practical way. That detail becomes interesting when you think about how systems we build tend to behave. Every digital system has limits. Screens have pixels. Simulations have resolution. Processing power is finite. You can't divide things endlessly without eventually reaching a smallest unit defined by the system. The resemblance isn't proof, but it adds another layer to the question. Why does reality have these limits? Are they simply features of how physics works, or are they constraints of something deeper? Now let's bring in computation, because this is where the conversation becomes more concrete and less abstract. Over the last few decades, we've watched computing power grow at a pace that would have seemed impossible not long ago. Simulations that once took massive systems can now run on devices people carry in their pockets. We can model weather patterns, simulate molecules, recreate environments, and build virtual spaces that feel increasingly immersive. None of these are perfect, but they are improving steadily. If you take that trend and extend it forward, not wildly, just steadily, it leads to a simple observation. There is nothing in the known laws of physics that outright forbids a system from simulating something extremely complex, even something like conscious experience. It would require enormous resources, but not infinite ones. And if a civilization were advanced enough, with enough energy and computing capacity, the idea of simulating entire environments with conscious agents inside them doesn't look impossible. It looks difficult, but within the realm of what physics might allow. This is where a specific argument enters the conversation. It's not saying that we are in a simulation, but that if simulations of conscious beings become possible, and if advanced civilizations create many of them, then the number of simulated minds could eventually become much larger than the number of original biological minds. And if that were the case, then statistically, any random conscious experience would be more likely to belong to a simulated environment than to a base reality. It's not a claim about certainty, it's a claim about probability under certain assumptions. But here's where it's important to stay grounded and not drift into speculation that sounds convincing but isn't supported by evidence. Right now, there is no experimental proof that we are living in a simulation. No test has shown a hidden computational grid. No measurement has revealed a boundary where physics suddenly breaks into something artificial. Every observation we have can be explained using existing physical theories, even if those theories are incomplete. The simulation idea fits within what is possible, but it is not required to explain what we see. Some scientists have suggested ways we might look for evidence. For example, searching for patterns in high-energy physics that might suggest an underlying structure, or looking for limits that behave more like computational constraints than natural ones. But so far, nothing has clearly pointed in that direction. And there's also a deeper issue. If a simulation were sophisticated enough, it might be designed in a way that makes it indistinguishable from a base reality from the inside. In that case, detecting it might not just be difficult, it might be impossible with the tools available to us. Now bring this back to your own experience, because this is where the question becomes less abstract and more immediate. Whether or not this is a simulation, your experiences are still real to you. The way time feels, the way emotions rise and fall, the way decisions shape outcomes, none of that changes based on what the underlying layer of reality is. If you feel something, you feel it. If something matters to you, it matters within your experience. Even in a simulated environment, those experiences wouldn't suddenly lose their weight or meaning. And there's something else worth noticing. Even in a world that is not simulated, your brain is already doing something very similar. It builds a model of reality from incomplete information. It predicts what's going to happen next. It fills in gaps. It creates a continuous experience from fragmented inputs. You never access reality directly. You access a version of it that is constructed in a way that helps you survive and function. In that sense, you are always living inside a kind of internal simulation, one that runs constantly without you noticing it. So the question, are we living in a simulation, starts to shift slightly. It becomes less about some external machine and more about layers. Layers of interpretation, layers of structure, layers of rules. Physics describes one layer. Computation might describe another. Your brain adds another on top of that. Each layer builds on the one below it, and at each step, what you experience feels complete, even if it's not the full picture. What makes this question powerful isn't that it gives a clear answer, but that it changes how you look at things you usually take for granted. The stability of physical laws, the existence of limits, the way reality behaves at very small scales. The fact that your experience is constructed, it pushes you to see reality not as something obvious, but as something structured in a way that we are still trying to fully understand. And when you reach the end of that line of thinking, you don't land on a dramatic conclusion. You land somewhere quieter, but more grounded. We don't know if we are in a simulation. Science has not confirmed it, and it has not ruled it out. The idea fits within what might be possible, but it is not necessary to explain what we observe. It remains a possibility, not a proven fact. But maybe the more useful perspective is not about proving or disproving it. Maybe it's about recognizing that whatever this is, whether it's the base layer of reality or one of many layers, it is the environment you are in. The rules still apply. Cause and effect still operate. Time still moves forward the way you experience it. Your choices still shape what happens next. So instead of asking whether this is real in some ultimate sense, a more grounded question starts to emerge. Given that this is the reality you experience, how do you move within it? How do you use the time you have? How do you respond to the things that happen? Because simulation or not, this moment is still unfolding. And whatever the deeper structure of reality turns out to be, this experience, right here, right now, is still the one you're living through. I post videos that break down how reality actually works, from your brain to your body to the world around you. So if that sounds interesting, subscribe, and I'll see you in the next one.